So 3.983 is basically going to simplify the exact solutions with and without imaginary solutions. So real quick, if I had to look at this, first thing you want to do is simplify the radical. Okay, so this would be 12 plus or minus, right, square root of 88. If I look, the largest perfect square that goes into it is root 4. Root 4 times root 22. So that's going to give me 2 square root 22 all over 14. Now what you have to notice is all of these outside numbers, right, can be divided by 2. So basically 12 divided by 2, 2 divided by 2, 14 divided by 2. If they're not all divisible by 2, you cannot simplify. So 12 divided by 2 is 6 plus or minus. 2 divided by 2 is 1, so that's the square root of 22 all over 7. This is one way your answer can be written. Another way would be as 6 over 7 plus or minus root 22 over 7. So it's very important to get used to both ways of representing the exact answer. Okay, so try the next problem on your own and then come back and take a look at your work. So negative 21 root 45 is going to become root 9 times root 5. So this becomes negative 21 plus or minus 3 root 5 all over negative 33. So basically everything now could be divided by 3. So we would have negative 7 plus or minus root 5 all over negative 11. Okay. So the next one. Now we see that we have the square root of a negative. So this is where it's kind of important. So here we're going to do 25 plus or minus the square root of negative 100 is going to be 10i, all divided by 5. Since all three of these terms are divisible by 5, right, we divide everything by 5, and that's going to give me 5 plus or minus 2i, and I am done. So the next one, very same thing, right? So simplify the radical, so this becomes negative 40 plus or minus the square root of this is going to be the square root of negative 1 times the square root of 25 times the square root of 2. So it ends up being 5i root 2 all over 15. Now, each of these terms can now be divided by 5. So what do we get at the end? Negative 40 divided by 5 is negative 8 plus or minus. This is just now going to be I root 2 all over 3. And I am done. Try the next two you try problems and come back and check your answers. So right away we get 21 plus or minus. That's going to be 12i all over 3. And everything can be divided by 3, so that becomes 7 plus or minus 4i over 3. And we are done. Okay, the next one, I'm going to simplify root negative 98 to root negative 1 times root 49 times root 2. So this becomes 14 plus or minus 7i root 2 all over negative 21. If I look now, all of these can be divided by 7. So I would get 2 plus or minus I root 2 all over negative 3 and leave it at that. Okay, so where this is important is if I'm going to solve quadratics now, okay, I can either complete the square or use quadratic formula. Many of us might use quadratic formula. So I find the discriminant, which would be negative 8 squared minus 4 times 1 times 13. And my discriminant here ends up being 12. So right away now, I get x equals, the opposite of b is 8, plus or minus the square root of 12, all over 2 times 1. But I have to know 12 can be broken up into the square root of 4 times the square root of 3. So 8 plus or minus 2 root 3 all over 2. Now, since all of these can be divided by 2, right, I end up getting 4 plus or minus root 3. Now, if I completed the square, I'd probably go straight to that. So if you use that method, it's actually pretty, it's a little easier. Okay. Now, the second example, okay, if I go to use quadratic formula here, my discriminant is b squared, so negative 12 squared, minus 4 times 3 times 1. So in this case, my discriminant would be 132. Okay, so now x equals, the opposite of negative 12 is 12 plus or minus the square root of 132, all divided by 2 times 3. The square root of 132 is the square root of 4 times the square root of 33. So this becomes 12 plus or minus 2 root 33 all over 6. Now, each of these can be divided by 2. So I divide everything by 2, and I would get 6 plus or minus the square root of 33 all over 3. And I am done. All right. The next one, first thing I have to do is set this equal to 0 by adding 3. I end up with 6x squared minus 8x plus 3 equals 0. So now my discriminant is going to be negative 8 squared minus 4 times 6 times 3. Okay, that will give us negative 8. Now technically this would be no solutions from what we did in the past, but now we're going to simplify it using the imaginary number I. So this is going to be, the opposite of b is going to be 8 plus or minus the square root of negative 8 all over 2 times 6. So in this case, we would get 8 plus or minus the square root of negative 8 is square root of negative 1 times the square root of 4 times the square root of 2. This is going to give me 2i root 2 all over 12. What can all of these outside numbers be divided by? 2. 8 divided by 2 is 4 plus or minus I root 2 all over 6. And we would leave our answer like that. Some textbooks would break this up into 2, 4 over 6, which would reduce to 2/3, plus or minus I root 2 over 6. All right. So either one of these answers you may see if it were, say, a multiple choice test. Okay. The last one here, my discriminant is negative 5 squared minus 4 times 2 times 8. Okay, so we know it's going to be negative. So 25 minus 4 times 2 times 8 is going to give you negative 39. So when we go to do the quadratic formula, the opposite of negative 5 is 5 plus or minus, right, the square root of negative 39, all over 2 times 2, which would give me 5 plus or minus I root 39 all over 4. The square root of 39 cannot be simplified. Therefore, we would leave our answer as is. Okay, so this should give you a good idea of where we're going with this imaginary solution to talk about the roots and the x-intercepts. Go ahead, take the notes, use the notes for your homework, and let me know if you have any questions.